tell me.
These are the bracket things.
Okay. 3.5, performing basic matrix operations. A matrix is a rectangular arrangement of numbers in rows and columns. Rows go horizontally, columns go vertically.
Yes.
Okay? So in rows and columns. For example, matrix A, right here below, okay, has 2 rows, 3 columns. The dimensions of the matrix would then be considered a 2 by 3. Bless you. So your dimensions of this is a 2 by 3. So when you talk about the dimensions, you're going rows by columns. Okay? It's important that you know that because in order to add matrices together or subtract matrices from each other, they have to have the same number of rows and columns. Okay? When we get to multiplication, we'll talk about what that looks like because it's a little different. But if you are adding and subtracting, it has to be a 2 by 2 added to a 2 by 2, or a 2 by 6 added to a 2 by 6. No 3 by 5 added to a 5 by 3. That's not the same thing. Okay? So they have to be the same. When you are adding them, okay, you take the first constant and the first constant in both and you add those together to get your new first constant. Okay. You take the second constant and the second constant, you add them together to get your new second constant. So it's like reading, you just take things in order.
Can you restart?
C and G add together to give you this new term, C plus G. And D plus H add together to give you this fourth term, D plus H.
Oh, this is easy.
So would that just be the same
This is
thing
like
for
biology
subtraction?
class.
Yes, it is like some
With those,
yeah, with the
Punnett squares.
yes.
I
Oh,
love
I just have
those.
you.
Okay. You also can do them by subtracting matrices, and it's the same rule. A minus E equals that first spot, B minus F, C minus G, D minus H. Yes.
So when we do that, like say like A is 4 and then the E
Yeah,
is
we're going to do numbers next. Okay.
like, so what do we have to leave it as number minus
No,
number? Or do
But
we-
you're going to write that step out, and then you're going to do what it says.
Okay.
Okay, so I'm gonna give you an example of it right here, okay? So this first one says 3, -5, 0, -1, plus -1, 2, 4, 0, okay? So when I go to do this, I'm going to show my work by saying 3 plus -1 in that spot, okay? This spot becomes 0 plus 4. This spot becomes -5 plus 2. And this spot becomes -1 plus 0. Okay? I want you to write this step out because I want to see where you mess up if something goes wrong. Okay? And then your final solution would be you condensing all this. So it would be 2, 4, -3, -1 is the answer to that matrix.
This seems so fun. I'm so
What?
excited.
Well, good question, Maddie. So I can use this because here's what happens. We're going to do a word problem with it later,
Oh.
but they can become your X and Y coordinates, your X, your Y, your Z coordinates, so that I can solve for things. Now, a lot of times in statistics, you'll use matrices to figure out problems later on or predict what's going to happen in the future for your company. We're going to use them off and on, yes. Okay. And on your ACT and your SATs, these show up every once in a while too.
Big.
Okay? Now, let's talk about subtracting this. Can I subtract these bottom two matrices from each other? Can I subtract these two matrices? Why?
Because they have the same number of row and column.
Okay, so what is the size of that matrix?
2 by
Rows?
3
by
by
columns.
2. Yeah. 3 by
3
2.
by 2. So I have a 3 by 2, and I have a 3 by 2, so I can subtract those, which means I'm going to get a 3 by 2. Okay? So, let's start by showing our work. The first section is 7 minus -2. 7 minus negative 2. The second one is 4 minus 5. Okay. 0 minus 3. Negative 2 minus negative 10. Negative 1 minus negative 3. And 6 minus 1. Okay. So now I have to write out what this equals. What is 7 minus 2? Negative 2. 7 minus negative 2. 9. What is 4 minus 5?
Negative 1.
What is 0 minus 3?
Negative 3.
What is negative 2 minus negative 10?
Negative 8.
Positive. Positive 8.
No, I'm sorry.
What is negative 1 minus negative 3? 2. And what is 6 minus 1? There's my new matrix. Can you handle those two things so far, adding and subtracting? Questions on adding and subtracting?
This is a piece of cake. Can we just like do this for the rest of the year?
What?
Oh, this really good. Huh?
That's, I was naming what size it is. It is a 3 by 2 matrix. Okay. I know. When you see it written like that, Emma, it's always going to be what it is by what. Okay. Like in measurements with wood and stuff like that. Okay. The next thing we need to talk about is called scalar. Clayton, focus. In matrix algebra, a real number is often called a scalar. What does scalar in geometry do?
Scale.
What does that mean?
It measures it.
Makes it bigger or
Or
smaller.
smaller, good. It
Good
makes
job,
it
Alice.
larger or smaller. So here, you have something called scalar multiplication on matrices. I'm going to change my matrice data and make it larger or smaller.
So you distribute.
So you distribute.
So it's just 8.
Oh, this is what
So
I'm
on
here
A, what would I do to get my new matrix?
Times everything by negative 2.
Yes, so
for. Oh my gosh, I love this.
what do you get up top?
Negative 8.
What do you get up top there?
2.
What about here?
Negative 2.
Here,
0.
here,
Negative 4.
and here.
Negative 14.
Good job, Alex.
Alright, I'm done for the day.
So when it is scalar, you do that. Now, over here on B, we have two things going on. You have scalar and you have addition. What do you think you do first?
Scale it.
PEMDAS,
Yes.
so you do multiplication.
PEMDAS, order of operations.
Yes.
Yes, perfect. So follow order of operations
Everybody
all
go.
the time. If you don't, if you add those matrices first and then multiply it in, your answer's going to be completely wrong. Okay, what?
So, does the 4 only apply to the first one?
Yes.
Okay, perfect.
Okay, so what does the first one change into?
Negative 8.
Negative 8.
Negative 20. No.
36.
36.
32.
32.
Oh.
4 times 5.
20.
And 4 times 0.
0.
Then I'm going to add it to, and I just drop this down. Okay? Can I add those together first of all?
Yes.
Yes. If I couldn't, I would stop there. Okay? And you would say something like, no solution, or not possible. If they cannot be added together because they are different sizes, or they cannot be subtracted from each other because they are different sizes, it is not possible. Okay? It's very simple that way.
Oh, no, I love this.
Okay, so what do I do here? Negative 8 plus negative 3?
Negative 11.
11.
Negative 11. Negative 32 plus 8?
Negative 24.
Negative 24, good. 20 plus 6?
26.
And 0 plus negative 5? Boom, there's my solution. Okay, there's my solution. That's all you have to do right now, yes.
Right.
Told you, today's easy, it's a warm-up. Okay. Right. If they are not the same exact size, you cannot add them together. So if I have a 3 by 2 and a 2 by 3, that's not the same size. Because a 3 by 2 would be 3 rows, okay? It'd be like boom, 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 boom. 3 by 2, okay? And if you have it added to a 2 by 3, that would be boom, 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 boom. You can't add those together because they don't match. Okay, there's nothing to match it to add it together. Yes, question.
If you think
Oh, I
about
was
it,
trying
it
to
couldn't
do
do
it.
much, but.
No,
also
no,
they
no,
don't.
no, no.
Well, yeah, I know, but.
We'll talk about it when we get to multiplication. We can do stuff with those for multiplying, but not that. Okay? Adding, it has to match, it has to be perfect. Okay, almost done, we got 2 things left.
Oh,
Okay, then you get a word problem, and it says matrices are useful for organizing data and for performing the same operations on large numbers of data projects or values. Okay, a company manufactures small and large steel DVD racks with wooden bases. Each size of rack is available in 3 types of wood: walnut, pine, and cherry. Sales of the racks for last month and this month are shown below. Okay, organize the data using 2 matrices, one for last month's sales and one for this month's sales. Then write and interpret a matrix giving the average monthly sales for the 2-month period.
I understand it now.
Okay. What, Jason?
Can I go use the bathroom?
Can I what?
Can I go use the bathroom?
Yes. Alex, stop.
I'm so
Focus.
sorry, I'm so sorry. Sorry.
Okay, so how can I set up matrices to help solve this problem? And I'm gonna give us more space. by
Well, you take the little, the data from last month, from the both thingies, and you put it in one.
Okay. Yes, from both thingies, you mean the large and the small?
Yeah.
Okay.
And then you do the same thing for this month.
But, perfect, so I make my first one, let's say my first one's for last month, okay? And I'm gonna say smalls in this row, or column, large, I said medium.
Gosh darn it.
Golly gee willikers.
Oh.
Well, I'm gonna take this one.
What did you say?
Is that a old person term?
It is. Okay.
Wow, Alex.
So, this is last month, so I have 125 for walnut, and last month for large, I had 100. So I'm gonna say 125, and I'm gonna say 100. I'm gonna say 278 and 251, so 278, 251. I'm gonna say 225 and 270. Then, I'm going to add it to
This month.
this month.
Small and large.
Yep,
Yes,
small and
Alex.
large, and you wanna make sure you label
Dang,
things.
you did really bad this one.
Oh, what?
No, I meant in the sales.
Oh, okay. So 95, 114, right? 316, 215. And 205, 300. Now here's the deal. Let's go back and reread this. It says you are organize the data using 2 matrices. Check. One for last month, perfect. One for this month's sales. Then write and interpret a matrix giving the average. What do you do when you average something?
Add them all.
Add them all together and divide by the
how
number.
many.
Okay, so
Add up
how
all the
many
numbers
are
and
there?
Divided by the number that is.
12. I can't do
How
math.
many matrices are there?
2.
2. So when I average these together, I'm going to take this and divide it by 2 or multiply it by 1/2, okay? So first I have to do what's in the parentheses and then distribute that 1/2 into it for the scalar for the average.
Oh my gosh.
Okay, not hard, you can do this, you've done it already. Let's make my new matrix. What is 125 plus 95?
220.
125 plus 95 is
220?
220. What is 100 plus 114?
214.
Good. What is 278 plus 316?
Oh wow.
Old number.
Wait, which one?
278 plus 316. 594. 594. What is 251 plus 215?
466.
466. Good. Wait. 225 plus 205.
430.
430. Good.
430. Sorry.
And what is 300 plus 270?
5, 7.
And then what do we have to do to this now to get the average?
Multiply it by 1/2.
Okay, so what's half of 220?
110.
110.
110. What's half of 214? 107. What's half of 594?
297.
Good job, Anna.
What's half of 466?
233.
What's half of 430?
215.
And what is half of 570?
235.
130.
285? 285.
What?
And so this now shows your average monthly sales of large and small in walnut, in pine, in cherry.
I think I actually like Google.
How was it by?
Oh, I know I do.
Because we were finding the
Yeah, I'd
average,
rather
and there were
not.
2 sets of data.
It could be worse.
I'd
Okay.
rather do this than the.
Now, last thing, okay? Let's solve for x and y in these. Don't get overwhelmed. It's very simple. I'm gonna show you. Okay? We know that this spot right here goes with this spot, and those two added together give me this spot.
Yeah.
So I can set up an equation that says, because I have a scalar factor out here, 3 times 5x plus 3 equals
-21.
-21. Can you solve that?
Distribute.
Yes. So you get
15x
15x plus 9 equals -21.
Yes.
15x equals -30. Divide by 15 and x equals.
-2.
Okay, so I solved for x. How would I set up the y one?
Do the same exact thing, but use the right numbers.
-4. No,
Negative,
3
yes.
times
No.
negative.
Yeah,
You're right.
you're right.
3 times -4 plus -y equals 24.
Plus -y equals -24.
Look at me go. Wow.
Okay, so do not get overwhelmed by this.
She really did that.
Because it really is that simple. You just match up the spots and set up your equation. Okay? So 3 times -4 is -12. 3 times -y is -3y equals -24. I add 12 to both sides. I get -3y equals -12. I divide by -3 and y equals 4. So your solution is a point.
-2, I love this. Oh my gosh.
And that is solving elimination and substitution in matrix form.
Let's go.
Wow.
I'm here for it.
It's actually.
Oh.